Hello everyone, good morning. Dear authors and invited guests, welcome to technical session 6D. Myself Tanish Virmani and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you all to the International Conference on Technological Intelligence and Business Strategies TIPS 26, Manila, Philippines. This conference is being organized in a hybrid mode. The physical event was held on 22nd June in Manila, Philippines, and the virtual event is being held through Zoom from 23rd to 24th June 2026. I hope you will all enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have total 8 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answer. After 10 minutes, I will raise a gentle reminder for the same. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any queries or updates, then you can write to us in the chat box. I would like to introduce you to the chair for the today's session. It is Dr. Amal Azerwal. Dr. Amal is a professor of computer science at Center of Guidance and Planning, Morocco. Her research interests include artificial intelligence, big data, biomedical engineering, educational technology, and computer science. She served as a reviewer for many international conferences and journals. Second chair for this session is Dr. Hirak Jyoti Hazarika. Dr. Hirokjyoti Hazarika is an assistant professor, HOD, and assistant dean of academic affairs at the Assam Royal Global University, Guwahati, India. His research interests include library automation, digital information systems, open source software implementations, bibliometrics, and the applications of artificial intelligence in information science. He is actively involved in teaching academic leadership, research, and curriculum development in modern computing domains. If we could have some words from both the chairs, it would be very nice.
Thank you for one introduction. Just I want to say that best wishes to all the presenter. So please follow the time schedule because we have a limited time allotment for this session. So you got around 10 minutes for presentation. Try to complete your presentation within the time schedule only. Thank you. Over to moderator.
Good, good afternoon. Good afternoon,
Yes,
everyone.
good afternoon. Yeah, good afternoon, ma'am.
Good afternoon. My pleasure to chair this session. I am Amal Azarwal. Good luck for everyone.
Thank you, ma'am. I would like to call the first presenter, Mark Bumakot, for the paper title Developing a Dynamic Landslide Susceptibility Model for Benguet Province Using Machine Learning.
Hello, good day, everyone.
You can start your screen sharing.
Okay, so is my screen visible?
Yes, it's visible.
Thank you. So let me start my presentation. So good afternoon, everyone. My name is Mark Jandibo Magad, and I am presenting on behalf of our research team, Afaga, Balang, Binwag, Bromeo, Calciman, Sindanya, and Monar, under the mentorship of Mr. Roderick Makil. So to set the stage, between 2004 and 2016, landslides claimed more than 56,000 lives worldwide. The Philippines, sitting on the Pacific Ring of Fire and battered by up to 20 typhoons a year, is among the most landslide-prone nations on Earth. And within the country, Benguet Province stands out as one of its persistently at-risk areas. Today, we present our work on developing a dynamic machine learning-based landslide susceptibility model specifically built for Benguet Province. To understand why Benguet demands attention, consider its geography. It spans 2,655 square kilometers of rugged highland terrain with elevations reaching up to 2,900 meters. It sits directly in the path of typhoons that can deliver more than 200 millimeters of rainfall in a single day. The consequences of this are not hypothetical. Baguio, La Trinidad, Itogon, Sablan, Tuba, and Tublai has been struck repeatedly. The 2018 Typhoon Mangkut disaster in Itogon and the twin typhoon impacts in 2025 are painful, recent reminders that this is an ongoing crisis, not a historical footnote. So this brings us to the central question that motivated our research. Are the tools currently being used to predict landslide risk in Benguet actually keeping pace with how disasters happen in the real world? The honest answer is no, and the gap has real consequences. Existing susceptibility maps for Benguet have largely relied on logistic regression, a linear method paired with static long-term rainfall averages. The problem with this approach is twofold. First, landslide triggering is inherently nonlinear. It emerges from complex interactions among slope gradient, soil saturation, vegetation cover, and rainfall intensity that a linear model simply cannot capture. Second, long-term averages are blind to the specific conditions of an incoming storm. A typhoon delivering 150 millimeters of rain in 24 hours behaves very differently from what an annual average can represent. Beyond the modeling approach, high-resolution satellite indices such as Sentinel-2, NDVI, and NDWI had not been integrated into local frameworks, and no updatable province-wide system existed. That is the gap we set out to fill. So our model is built on 13 conditioning factors organized across 5 domains. Topographically, we use elevation, slope, aspect, and distance to stream, sourced from the Copernicus digital elevation model. For geology, we incorporated rock type and soil type from the Mines and Geoscience Bureau data. Under land cover, we included land use and land cover classification, along with NDVI and NDWI derived from Sentinel-2 imagery at 30-meter resolution. So for climate and hydrology, and this is where the dynamic elements comes in, we use mean annual rainfall from CHIRPS alongside event-based and antecedent rainfall from GPM iMerge. So these two rainfall variables allow the model to respond to an actual approaching storm, not just historical averages. And finally, for the anthropogenic domain, we included distance to roads from OpenStreetMap. So all 13 factors were processed across approximately 4.2 million pixels, covering the entire province at a consistent 30-meter resolution. So we trained and compared two machine learning algorithms on a balanced data set of 16,158 samples, so equal parts landslide and non-landslide points, partitioned into 60% for training, 20% for validation, and 20% for final testing. So the first is random forest, which constructs many independent decision trees and aggregates their prediction through a majority vote. So it is robust, interpretable, and well suited to high dimensional tabular data, making it a natural baseline for the study. So the second is the XGBoost, which takes a different approach. So it builds trees sequentially where each new tree is specifically trained to correct the errors of the one before it. So the sequential refinement generally yields better generalization and higher recall, meaning fewer actual landslide areas are missed. Both models underwent rigorous hyperparameter tuning through five-fold cross-validated search over 200 iterations to ensure we were comparing their best possible configurations. So we did not rely on a single form of validation. Instead, we evaluated our models across three complementary dimensions. First is statistically, using accuracy, precision, recall, F1 score, and AUC-ROC, complemented by McNemar's test to determine whether any performance difference between the two models was statistically meaningful rather than coincidental. The second is spatially. So through the Seed Cell Area Index or SCAI, which assesses whether the high-risk zones identified by the model actually correspond to where real landslides have occurred. And the third is through expert review. So four geoscientists from the Mines and Geoscience Bureau here in Cordilleran Administrative Region, each with 7 to 9 years of field experience in Benguet, independently evaluated our factor selection, inventory quality, and model outputs. So what did the results show? So XGBoost outperformed random forest across every metric we measured. On the held out test set, it achieved an AUC-ROC of 0.89 with 81.8 accuracy, 81.9 precision, and 81.6 recall. Importantly, McNamara's test confirmed that this advantage was statistically significant. So XGBoost corrected 39 cases that random forest misclassified, while random forest only recovered 19 that XGBoost missed. So it also produced fewer false positives, so 37 versus 46 for random forest, meaning is fewer unnecessary evacuation alerts for the same level of protective coverage. Feature importance analysis consistently pointed to rainfall as the dominant driver. Mean annual rainfall, event rainfall, and antecedent rainfall together accounted for the largest share of predictive power across both models. So this confirms what the literature has long suggested. Landslides in Benguet are fundamentally shaped by the interplay between long-term climatic condition and acute storm-driven triggers. Spatially, the SCAI validation showed that the high and very high susceptibility classes, representing only 36.3% of the province's land area, captured 69.87% of all inventoried landslide. So that concentration ratio is strong evidence that the model is not just statistically sound, but geographically meaningful. On the map, risk concentrates on specific identifiable areas: Itogon, Atok, Kapangan, Mankayan, and Bukod, locations where steep terrain, active mining activity, and road networks converge. So a susceptibility map that cannot be updated is only partially useful. So conditions in Benguet change every month, vegetation recovers, roads expand, and rainfall patterns shift with each typhoon season. So rather than producing a one-time output, we designed the system to update itself. So every month, an automated pipeline retrieves fresh Sentinel-2 imagery and rainfall data from GPM iMerge, preprocesses and realigns all inputs, recomputes NDVI and NDWI, and runs the full 4.2 million pixel province through XGBoost to generate an updated susceptibility map. No manual retraining is required for routine updates. In practice, the complete monthly cycle takes approximately 31 minutes, so the majority of which is satellite data retrieval. When new landslide inventory data becomes available from the Mines and Geoscience Bureau, a full model retraining can be triggered by an administrator and finishes in under minutes. The entire system runs on free-tier cloud infrastructure, making it financially sustainable for government agencies and academic institutions at near zero recurring costs. So this study was designed with practical application in mind. So local government units can use the updated susceptibility maps for pre-typhoon evacuation planning at the barangay level. Pagasa can integrate rainfall forecast data directly into the pipeline to generate near real-time risk assessment. MGB CAR, or the Mines and Geoscience Bureau, gains a validated machine learning derived reference to supplement its existing geohazard maps. And most importantly, communities gain access to an up-to-date picture of the risk before a disaster, not only after one. Looking forward, our expert reviewers identified two priority improvements. The addition of distance to fault is a conditioning factor, and the replacement of NDWI with the topographic wetness index for better hydrological representation. So our longer term roadmap includes integrating real-time rain gauge data for sub-hourly predictions, adapting the LiDAR derived elevation models for finer barangay scale resolution, expanding the framework across the broader Cordillera region also, and ultimately developing a mobile alert layer to push risk warnings directly to residents. So to bring everything together, this study demonstrates that machine learning, specifically XGBoost, trained on 13 multi-domain conditioning factors, can produce a landslide susceptibility model for Benguet province that is statistically robust, spatially accurate, and practically deployable. So, three contributions stand out. First, the integration of dynamic event-based rainfall variables moves susceptibility modeling beyond static historical averages, making the output responsive to real weather conditions. Second, the automated monthly update pipeline ensures that the map does not go still between disaster events. Third, the triple-layer validation, statistical, spatial, and expert, provides the kind of methodological confidence that agencies like MGB-CAR and LGUs require before acting on model outputs. Ultimately, landslide risk in Benguet will not disappear, but with tools like this, decision makers have a clearer, more current picture of where that risk lives, and that matters when lives are at stake. And we remember that mountain will keep moving, but now we can see it coming. So thank you very much. I welcome your questions.
Yeah, Mark, it's a nice presentation. Even I appreciate your designing of a presentation, also excellent. It's a very much accuracy. It's very nice to see the presentation, how AOA is designed. Next, I have a simple one question. Just I want to know, could you explain the significance of the seed cell area index in validating landslide sustainability or accessibility maps?
Can you repeat the question, please?
Can you explain the significance of seed cell area index in validating landslide maps?
So actually the spatial validation or the SCAI, so it focuses on the model. It shows that a model can perform perfectly on data points statistically, but still produces an illogical map in space. So spatial validation like the SCAI checks whether areas predicted as high or very high susceptibility actually match where historical landslides physically occurred. So the continuous probability output stack was classified into five hazard levels, so very low to very high, and the total surface area percentage of each class across Benguet was then crossed against the actual coordinates of historical landslide points using the seed cell area index. So that's it.
Mm, okay, got it. But if you see your data set, it is showing that your balance is 50-50. How would that model perform on a real world imbalanced data set?
Sorry po. Can
If you see your data set, it is showing that the data set was balanced with 50-50. Am I right or wrong? You see the presentation, it is showing 50-50. How would a model perform on a real world imbalanced data set? Now it is showing 50-50. You see the in the next slide.
um let me
Your data set, your
go
data
back to
set.
that
I'm saying
slide.
data set, data set, data set, data set.
So
Mm. Where is the data set?
yes.
Next you go.
Um yeah, the data set were divided into 50-50 so that it wouldn't introduce a bias from both the target variable, the landslide and non-landslide. So it wouldn't introduce bias to the models.
Okay, got it. Now I just about to Amol ma'am, if you have any question, please ask to ma'am.
Thank you, John, for your interesting presentation. I have a question. How could this model be adapted for the other regions with different geological and climatic characteristics?
So it would be different for other regions because other regions might introduce different factors than what we have used, like the Benguet, since Benguet is known to be on a highland. So maybe other regions could introduce other factors and make the model um, um, improve to target or um, to what do you call this, to to identify um, areas for landslide and non-landslide prone areas.
Okay, thank you.
Thank you very much.
Thank you
Yeah,
for the
over to Tanish.
presentation. Yeah. I would like to call the next presenter, Adhibav Agarwal, for the paper title Development of a Real-Time EMF Monitoring System and its Application in Assessing Electromagnetic Exposure Effects on Animals.
Hi.
Yeah, you can start your screen sharing.
I don't know. No, it's not working. Yeah, sorry. So I'm Adibhav Agarwal from Boys High School and College, Prayagraj, India. We are here today to discuss our project, the development of a real-time EMF monitoring system. This work meticulously studies IoT integration in precision livestock farming. Our focus is on innovation in agricultural technology and animal welfare. I believe this research offers significant advancements in understanding environmental impacts on livestock. Now, we move into the critical problem we are addressing. The rapid growth of wireless technology means EMF exposure varies widely in agricultural settings, but current research relying on spot measurements misses this dynamic reality. We aim to bridge this gap by developing a low-cost, real-time EMF monitoring system for continuous data collection. Building on the problem of inconsistent measurements, our literature review reveals a clear significant bias for concern. A significant majority of studies show biological responses in animals to RF EMF, often linked to stress and behavioral changes. This happens because EMFs can disrupt cellular processes, leading to oxidative DNA damage. This highlights the urgent need for long-term, calibrated monitoring data to truly understand these correlations. Now, let's look at how we build the system to address this void. To address the monitoring void we just discussed, we designed a robust system architecture. The ESP32 acts as the brain, handling processing and Wi-Fi transmission. We chose the MLX 9093 for its high-precision 3-axis EMF sensing. Power management is handled by the TP4056, and an OLED display provides real-time local visualization. All these components are housed in a custom 3D printed PETG enclosure. Built to withstand harsh burn conditions, this design ensures both accuracy and durability in this field. Moving from the hardware components, we integrated them through careful circuitry and firmware development. We used an I2C bus for efficient communication between the sensor and the display. Our software developed in Arduino IDE leverages Adafruit libraries for data acquisition and visualization. Most importantly, we implemented real-time data publishing via MQTT every 5 seconds. This ensures continuous, low-latency data transmission, which is crucial for capturing dynamic EMF changes. Now, let's talk about how we put our system to the test. We deployed a real-time EMF monitoring system for 28 days in a working dairy farm, strategically placing devices in 3 distinct zones. We chose these zones to capture the full spectrum of potential EMF exposure, from high-intensity areas near electrical infrastructure to baseline zones at the barn's perimeter. And we just didn't monitor the environment. We also tracked 12 Holstein Friesian cows for key physiological markers, giving us a complete picture of both exposure and response. This comprehensive setup allowed us to gather robust data on both environmental EMF levels and their direct impact on animal welfare, setting the stage for our findings. Moving from our setup, let's dive into what we found regarding device performance and the spatial variation of EMF. Our system proved incredibly reliable, boasting a 98.7% MQTT delivery rate and zero sensor reset events over the entire 28-day period. But the real eye-opener was the spatial heterogeneity of EMF gel levels. We observed an 18-fold difference between the milking parlor and the barn perimeter. This dramatic gradient highlights how localized electrical infrastructure creates pockets of significantly higher exposure, a crucial insight that spot measurements would completely miss. So we've established that our system works and that EMF exposure isn't uniform across the barn. Building on the spatial variations we just discussed, let's examine the direct physiological and behavioral impacts on the cows. We found a strong negative correlation between cumulative EMF exposure and milk yield, with high exposure cows producing 1.8 kilograms less milk per day. This isn't just a minor fluctuation, it's a significant economic impact. Further, we saw a substantial increase in serum cortisol levels in the high exposure group, jumping from 12.7 to 18.3 nanograms per milliliter, a clear indicator of physiological stress. These findings clearly demonstrate that EMF exposure isn't just an environmental factor, it's directly affecting animal productivity and well being. And this leads us to a deeper discussion about the underlying biological mechanisms. This work represents a crucial methodological shift, proving that continuous monitoring is vital because spot measurements simply cannot capture the dramatic spatial heterogeneity of EMF levels. Looking ahead, our future work will focus on integrating this EMF monitoring system into automated farm management levels. This will allow us to optimize animal welfare and productivity through real-time environmental adjustments, truly moving towards smarter, more humane livestock farming. Thank you.
Thank you for your presentation and timely finishing the presentation. This is a nice presentation.
Thank
Can you tell me your BTech student or MTech student?
Sorry,
You are MTech or BTech student?
I am currently in grade 12th
You are in 12th.
in Prayagraj, Uttar Pradesh,
Okay,
India.
okay. Okay, got it, got it. Just
And my mentor is from Mumbai and he
okay,
guided me on this project.
okay, got it. That's nice project. Just I want to know the challenges. Okay, challenge did you face any monitoring sensor accuracy over 28 days?
No, actually, what happened was, like the different EMF levels which we observed, that was quite detrimental to the cows as well as the animal, in the farms. So what I observed was that it's just isn't like something which is, a steady thing. It's not plateauing. It's moving to and from, oscillating, vacillating from, day to day. So I think that was really important, and that's what I, tried to emphasize in my
Okay,
presentation.
got it. Yeah. So over to Amal ma'am, if you have any question to the presenter, please.
Uh, thank you for your sharing your valuable research with us. I have a question. What are the next steps for validating these findings on larger scales?
Yes, ma'am. So that's what our future scope is based on. I want to develop more versions of this sensor. This was just a beta version for my research as well as testing. So I would like to move on and, even try to assess many more animals such as hens and horses, and, that will be my next step, I believe. And actually, the radiation and EMF levels, people are not really concerned about this, but it's actually a very, very detrimental factor for animals. And, it's indirectly related to us as well. And this is something which we clearly do not understand clearly.
Yes. What is the main practical implication of your study?
So the main practical implication was to, aware farmers that you need to be keeping the animals away from the radiation towers, the cell mobile towers. And I also wanted to assess how these EMF levels are actually, changing the milk yields of cows. Is it actually a detrimental factor, or is it just a false value? So that's what the aim of my project was.
Okay, thank you.
Thank you, ma'am.
Over to Tanis.
Thank you so much. Thank you for the presentation. There are two presenters presenting, Viraj Bhatt and Rajvi Bhimani, for the paper title Edge Optimized YOLO V8 for Real-Time Military Camouflage Detection on NVIDIA Jetson Nano. Viraj Bhatt and Rajvi Bhimani.
Yes. Am I audible?
Yes, you are audible. You can start your screen share.
Okay. So, good morning, everyone, and namaskar from India. I, Viraj Bhatt, welcome you all, where we will present the paper Edge Optimized YOLO V8 for Real-Time Military Camouflage Detection on NVIDIA Jetson Nano. So, first, I'll start with motivation. Motivation, what made us choose this topic? So, I would like to bring a few articles from the papers. Here you may see that the armed militants were in camouflage and police uniforms when they started firing towards the civilians. And this is not just one of the incident. There are many such incidents where you will find that the militants are using camouflage uniforms or as such tactical gas to ambush the people. So you may visualize this is one of the example of it. So if you see the map of India, I have highlighted three major regions where this problem is consistent. Number one, that is Jammu and Kashmir, that is claimed to be a Pakistan occupied Kashmir region, where cross border infiltration is a major issue. Another side, when we come to Northeast India, there is a group of militants who demand their own separate state or separate land. So there this kind of activities are seen, known as cookie militants. And if we go to Chhattisgarh and Jharkhand borders, this region, that is forested districts of these regions, there the Naxalism is one of the major issues. So it is very rightly said by the Chief of Defense Staff, the first Chief of Defense Staff of General Bipin Rawat, that India is fighting a 2.5 front war. The two fronts are outside the border of the India, and the point five is these guys which are mentioned in the pitch. So there is an internal threat to the national security from these people, and hence, if we could contribute towards detection of it, it would be grateful. So there are challenges to it, such as texture and gradient neutralization. So the military camouflage is designed in such a way that it blends with the environment, it blends with the background. So the standard gradient approach, where we take the difference between two pixel values, is not useful, as both the pixel would be kind of same. So we need to adapt something else or appear apply transfer learning in order to achieve this. Another problem is centralized transmission vulnerability. So it is possible and it has been implemented that in present models that the video stream or the surveillance stream is sent to the servers, and then the detection happens on that server based, and then again the stream is sent back. But challenges to this are the first will be the latency, and another one, if there is a jammer or there is can be a spoofing, so that is a major issue towards it. And next, to solve this, we need to apply edge resources where the computation happens locally on board, such as RPi or Jetson series of NVIDIA. And if we look forward to apply that, then we need to see the constraints of that board as well. That board has limited memory, limited architecture, it has thermal throttling, it has its own capabilities. So we need to look forward to everything. So I will come to the literature review that we did. It is kind of linked to this table, so I will keep on switching between this. So first, we saw the search and identification network, that is SINet by Fan. So they did desktop-based computation, and again, it was not server-based, but it was desktop-based. So the heavy computation happens on desktop side. Now the problem is if it is to be implemented on ground in the military, so we cannot have heavy desktops deployed where the people are deployed. So we need to make a optimized edge device. Next, that is Camo and Chameleon datasets were available, but these are benchmark for standard detection, such as detection of image insects or animals. So we need to come up to detect military grade camouflage. Next, that is edge models like SSD mobile net. It is lighter version of what we have did, but again, it comes at accuracies. It is not very precise so that it can detect military camouflage. And our proposed solution, we are using YOLO V8 Nano, and we have successfully achieved 95.5% of average accuracy over the model, and these are the other results. So I would like to justify why we chose YOLO V8 Nano itself. So you can see the comparison of the models. We need to identify the capabilities of Jetson Nano board itself. It has 4 GB of DDR4 memory that is shared between the CPU and GPU both. So it is a unified memory architecture, and that we need to take into consideration. So we have selected the model which uses only 2.4 or approximately 3 GBs of VRAM, leaving the other space for other computations. Next is the implementation part. Here we'll discuss what we did to implement it. So we took a data set that already contained the pre-augmented images. So we used them, we split them into 8:1:1 ratio of train test validation. Then we conducted pilot run for these 3 learning rates, and we found out that the 0.005 learning rate was giving good accuracy. So we picked it up and we went further with it, and we picked up the item optimizer and implemented 5-fold validation strategy. So the 5-fold generates 5 separate results. So average value is of those 5 results, and the best value is from the best. We also extended the number of epochs to 45, and we found out that from 30 to 45 epochs, there is no as such more increase in the accuracy. So we already achieved 95.5 in 30 epochs itself. So we consider it as a final result. Next, we need to deploy it on Jetson Nano hardware. So it has its own Maxwell architecture. So we need to convert it into an .engine file so that it is compatible with the architecture. Next, we also deployed it on device that is remotely capable of operating through SSH client, and we can access the terminal through PuTTY software and directly operate it from a distance.
Hello, this is Raji. I will be carrying forward. Am I audible?
Yes, yes, are audible.
Okay, so now the input has been taken through the camera sensors. They take the pictures and they are sent to the video stream is sent to the GStreamer acquisition, and this is then the raw buffer is sent to pre-processing, where it resizes the image to 640 cross 640, which is the ideal size for the YOLO tensor to identify the image. Then this is pre-processed and visualized. Our YOLO model looks for each frame and finds the camouflage target. Once it finds it, it draws boxes around them, and finally, all of this is sent to the sent securely over the Wi-Fi to the operator sitting at the remote screen. So, in short, the camera sees the model, detects, and the operator gets the clear view. Now these are the results. We tested the model carefully and it performed really well. On average, it got about 94.8% accuracy. Our best reach was 95.5%. The precision was high as the model detected 1688 targets and only missed 108, which is a really good ratio, as it in a military surrounding it is very critical to miss it is very critical to not miss a target, as a missed target will be a missed threat. Now this shows the result of our detection. The graphs going downwards shows the errors which are dropping, which is good, and the line going upwards are showing the scores that they are rising and that the training is giving a good result. The one second, can you go back? This shows that the model is not just memorizing all the images and data that has been fed to it, but it actually learns how to detect a camouflaged area and how to detect a person in a camouflage, and it gives us the detection of the camouflage accordingly. Change. For a small device, the big question is that it can handle it without, can it handle it without overheating? And the answer is yes. The GPU stays at around 39.5 degrees Celsius. The CPU temperature is reaches a stability maximum of 40 degree. The active memory footprint remains on an average of 2.4 GB. Dedicated shared GPU RAM allocation consumes approximately of 500 MB. System safety buffer utilizes 1.9 GB swap partition. Now these are the few of the detected images of detected by the YOLO. Robust texture segregation. It successfully distinguishes the image in a low contrast camouflage pattern, which this data set of 7,047 images featuring multi-angle rotation was used to train the model, and it measures it does not miss a lot of threat. It has uh, a good ratio of detection, which is 1688 true targets and 108 false targets. This system can be used on drones, military vehicles, and border posts. It connects easily and securely with existing command system. For the future, we plan to add automatic tracking using drone, a system, remote system where the final decision always stays with the human operator, or night vision support using thermal sensors. I'd like to thank my university, Nirma University, and Department of Electronics and Communication to help me to support my work. To wrap up, the problem was that existing system either needed big or powerful computers which were not possible to deploy on remote areas, and they lose accuracy on small devices. None of them really fit the military standards. So our solution to this was that we built a small, fast model, just 5.9 gigabytes, that runs on the tiny Jetson Nano and gives a 95% accuracy and runs smoothly at 10 to 12 frames per second and uses very little power, stays cool even after a lot of time, and it also keeps soldier at a safe distance while staying fully in control. And it supports the UN goal for peace innovation. Thank you. Now I'm open to any questions.
Thank you, presenter, for the nice presentation. Just I want to know one thing here. Have you considered incorporating thermal imaging alongside RGB imaging?
No, sir. Right now, we have only focused on the RGB images. We look forward to implement thermal as well as infrared in future.
Okay, just I want to know one more thing. From where you are collecting data images?
Yes. So data set is available publicly on RoboFlow.
Is it copyrighted or it is free to access?
No, sir. It is pre-augmented.
Okay, thank you. Over to Madam. If you have any question, please ask to the presenter.
Thank you for this interesting presentation. The proposed solution combines high detection accuracy with low power hardware development, making it suitable for field operation. How does the system perform under different weather or lighting conditions?
Right. So, ma'am, the operating range of this product is between about 20 to 60 degrees Celsius. We have not tested it anywhere on the deployed stations. It is under the research. Once if it is finalized, so we can put it forward and test it on military locations as well. And secondly, it will operate good because if I come again to the PPT, there was a thermal results where we went on detecting for multiple hours and we saw that it is remaining temperature, the temperature is remaining stable. So thermal bottleneck is not an problem.
Okay, thank you. That's enough. Thank you.
Okay, thank you.
About to Tanesh. Tanesh, please reduce the time for presentation. These participants are taking so longer their presentation.
Sure. We'll stop it at around 7 to 8 minutes and then rest of
Okay.
the question answers would do.
Okay, please.
Okay.
The next presenter I would like to call is Mr. Kapil Mohan for the paper title ESG Ratings Prediction, a study using machine learning approaches.
Thank you. Thank you, Tanish. Can you hear me?
Yes, sir, you're audible. You can start your screen share.
All right. Good afternoon to all the conference professors and the participants. So a quick introduction. I'm a research scholar at MIT. I'm a part-time research scholar. My broad area of research is AI in finance. I also work for a bank as a technologist. So this is one research that I'm doing with my guide, Dr. Ritu Chauhan, who is the head of AI in bioinformatics here, and Miss Harleen, Dr. Harleen Kaur. So this is our presentation roadmap. I will be talking about ESG and what it is and what's the motivation behind it and how it can help the financial institutions and traders to make a quick decision around risk and their other financial decisions. Then I'll be talking about literature review, the machine learning models that we have used, the results and discussion, and how it can fit into the overall workflow of traders. So yeah, let's start. What is ESG? ESG is basically environmental, social, and governance parameters that are provided by certain group of companies that are registered under the regulatories, and they provide those parameters. And certain companies like Sustainalytics and SVG, S&P Global, they run their quant models and they use those parameters to come up with the ratings. Social and governance, these are very much controlled because of our legal and the government policies and the regulators. But environmental is the upcoming thing because we want to be under containment of the carbon footprint, and there's a tax implication as well here. So ESG in today's financial ecosystem, we have like 35 trillion plus dollars in which are under assets under ESG management globally. 1200 plus firms are registered in NYSE, from where I have pulled the data. The frequency of publication is annual, so this is the problem that this research actually adheres to. The ratings comes in from 0 to 100 scale. All right, and okay. The core problem with ESG ratings right now is the time lag, because the ratings are released once per year by the analytics firm. Uh, Ratings only for certain firms, and if we have to predict for other firms or the traders or the financial institutions have to take decisions on certain companies or to take a long-term view on the company, then this research can help them. And there are proprietary quant models that are used by the analytics firm, which are difficult to audit and challenge. Okay. So this is our problem statement. Can we detect near real-time ESG ratings for financial firms using publicly available market fundamentals and business performance indicators? And investors, so at the end of the day, we want a tool so that we can get those ratings and do our financial prediction, basically. So these are the research objectives. We will predict ESG ratings. We will have a robust architecture design. We will do a model comparison and an investor utility that can help them. Whatever the model that fits in, it can be trained overnight and should be incremental, basically, so that the ESG ratings are live and could be used while trading. This is some of the literature that has already happened around ESGs. Okay. This I have already talked about. So I have made a verbose PPT so that we can basically help it. Okay. So uh, yeah, one second. Yeah. So this is the ML studies that have happened before. We had papers that says like, okay, we can predict ESG accurately. And then there's one that says strong ESG score prediction from fundamentals. But so this is my base paper from this is done by Cripple. Okay, dynamic network based ESG predictions. ESG ratings are time consuming to compute dynamically. Graphs offer a speed advantage. Then there is one thing that we focus on financial fundamentals, basically. So whatever financial fundamentals that are available out of the market live, we will feed into that model, and that model which will actually predict the ESG rating for that day. Okay. Yeah. Okay. So these were the gaps that were identified. Uh, uh, yeah. Near real-time prediction from live data that is not available in current literature. We have global multi-asset of 1200 plus firms only, and there are many firms and many different exchanges, basically. This is a self-updating architectures pipeline and a production-ready pipeline with live market feeds. The data set is basically from Kaggle. This was a base database that was available. Then I scraped using the Yahoo Financial API for NYSE, and I use the Bloomberg Sustainalytics ratings to train those models, do the classification, basically. So the ratings that were available by the analytics firm, they were from 0 to 100, like I said. So I basically did this classification. I talked to a domain expert, and he said, okay, these ratings classes should be used. And the features, these are the live calculations that uh, the pipeline does over the live market data, and then this is fed into the model, basically. Okay, so okay, let's skip that. So we have done the normalization because live market data, because some firms are publishing certain data or not, if we have to ignore those data, or you basically interpolate like what should be the value of that feature. So that part is handled by log scaling. Okay.
Excuse me, sir.
So
This is
yeah.
just a dental reminder that the presentation time is up. You can conclude in a minute or two.
All right. Okay. So basically, I have run these certain models, right? KNN, Gaussian, random forest, and support vector machine. And then this is the model that suited our best because it was incremental, and if you see the the comparison here, right? The accuracy and F1 score was pretty good for SGD. Yeah. And okay, let's skip that. Key findings: SG domain dominates for dynamic data. ESG is a classification problem. There are no ESG available for small and mid cap, which this model can actually help us. Okay, yeah. For the okay. Yeah, so this is the actual use case for the traders and the financial institutions. Like they can use this, they can feed into the live data and they can get the prediction for ESG. Future work, so I will come here. So I'm working on currently the pillar level e-score prediction. And because the BARSR, if you see here, right, third point, BRSR is business responsibility and sustainability reporting. These reportings are done by certain firms in India. So I am working on a research paper so that we can capture the ESG ratings in India as well. These are certain the parameters so that the results are reproducible. Acknowledgements. Yeah.
Yeah, thank you so much for your presentation. And just I have a one query only.
Yeah.
How you are going to stabilize the prediction during period of market volatility?
Sorry, I didn't get your voice.
Am I audible to you?
Yeah.
Uh, how stable the prediction during the period of market volatility?
Yeah. So, sir, the thing is, because this is a trained model on like 3 years data, so
Mm.
it captures all the volatility spikes. That's what we expect.
Okay.
And the thing is, like volatility, instant volatility won't help us. But because this model is getting trained overnight, so whatever the
Mm.
delta is there, right, we will train that model overnight, and that model is available for next day's prediction. Yeah.
Okay.
So
You
yeah.
mentioned also KNN model. Okay. I think go to the models. Just I want to see. Go to the model slide.
K nearest neighbor.
Yeah, KNK model. For what
Yeah.
purpose you are your KNN model? You what purpose you are using KNN model?
So K nearest neighbor is so we want to do classification, right? So we want
Yes,
to
exactly.
classify.
So
Yeah.
yeah, okay.
Yeah. So we want to classify the data. Okay. So these companies are similar looking and they have the same ESG rating.
Okay.
So if I have the new company that is coming in from the live data, I calculate
Oh,
all the fundamental ratios and feed into the model. So I can use
mm,
KNN as well. Yeah.
got it, got it. Because I also use KNN model for some classification of additional
Correct, sir.
songs and something like that. Just one more thing. This is a PhD research work or other thing?
This is a PhD research work, sir. Yeah.
Okay, fine. Thank you.
Thank you.
Over to ma'am.
Thank you for sharing your funding and your contribution. The study highlights the growing importance of sustainability metrics in investment and decision making. Which variable were found to have the greatest influence on ESG rating prediction?
Which one? Sorry.
Which variables were found to have the greatest influence of ESG rating prediction?
Oh, so uh, there are certain firms that are publishing the overall carbon footprint and the energy consumption. So I think that impacted the E parameter, ma'am, the most. So we actually in my the next research paper, right, I am analyzing that as well, like which parameters actually affect the E parameter, which is because we are going into taxation and whatnot. So the bad E for a firm will result in more taxation. So see, so this research can help there basically.
Okay, what will be the next step of your research?
Uh, so this I have the model is trained on NYSE data because when I started the research, I was not able to get the data for Indian firms. Now BRSR has come in wherein they have published the data from 2023 onwards. So I want to see like, okay, how, what model, and how can we, so that would be a PDF file which has all the water requirements, carbon footprint. So that would be more focus on Indian firms and particularly on the E part of it. So we can say, okay, if I am an investor, right, I want to invest in a firm which is a more carbon neutral firm so that, they have more sustainability in the years to come.
Okay, thank you.
Thank you, ma'am.
Thank you for the presentation.
Thank you so much.
I would like to call the next presenter, Anuj Kothavade, for the paper title Internal Assessment Module for Educational Institute.
Request to presenter, please try to complete your presentation within the time slot.
Audible?
Yes, you're audible. Anuj, you may start. Your screen is visible.
Yes.
Let's make it full slide mode. Go to slideshow and just click
Yes.
full slide.
Now is it visible?
Yes, yes.
Hello. Yeah, yes. Good morning to one and all. Myself Anush Kothawade, and on behalf of my team, I'm representing our paper that is Internal Assessment Module for Educational Institute. Uh, the thing is now the problem that we faced, the problem that we detected. As we know that nowadays the systems, the internal assessment model systems are pretty much old-fashioned, or we can say that they are outdated. So nowadays, the main thing that one should have is its own database. If an institute is planning its own learning platform, they should have their own database, they should have their own assessment model, and they should have their own uh, website and things there, so that there is no problem of privacy or uh, other aspects. So the main thing is first is of data silos, uh, close third-party LMS restrictions. We know that the database is of third party as always for many institutes. So here the learning assessment model that we are proposing is we have our own database. Second one is of manual grading. As we know, the manual work takes around 40 to 50 hours or more than that for a single assessment or of a class. This can be replaced by our system. And other than that, limited analytics. The thing is that traditional assessment and all these things doesn't provide us with proper analytics what we want. We cannot get a personalized analytics of our scores and uh, performance. So these problems are identified for our project. So what are the solutions that we are proposing? First of all, integrated and dynamic backend, which can be integrated with the database, which is the Firebase that we are using. This system basically, Firebase is fully integrated and is of full control with ourselves. Uh, like the we don't have the third party to give access of data. So the second one is of automated assessment quizzes and coding platform. Like we can see that we can just go through assessment, and we can uh, get our personalized scores through PDFs or reports that are generated when once we have attempted the quiz and we have presented our performance. Then there is interactive dashboard is designed by us, and mainly our tech stack is TypeScript, React, Tailwind, CSS, and Firebase. This is basically the integration of front end, back end, and database that we have integrated for our personal use, and now we are trying to implement it on university level base. These are the key contributions. Basically, data sovereignty. The data will be with ourselves. Then second one is of automated assessment, uh, and third one is of dual feedback loop. Dual feedback loop means teacher as well as student both can have their own personalized analytics through report. So this system. What is our framework? React front end, custom hooks, and Firebase backend. So backend is just integrated with front end through hooks, and from this we can basically have a system which gives us a smooth and seamless orientation. This is the basic methodology and architecture. As we can see, there are four containers: front end, logic state, backend, and core technology. Front end is basically designed through React, CSS, Tailwind components. Framer and Lucid icons are new design tools which are used here. Then we come to logic state. In logic state, authentication role is being used. Basically, we can set some parameters for authentication. Then, obviously, custom hooks is used. And third one is
Please
client
go to
side
summarize. Please summarize your
PDF.
presentation.
Uh, yes, yes, yes. So these are the graphs basically. These are the performance that we can see as student performance can be seen as per 15 students were taken, and uh, by their analysis we have presented these graphs. And this is our system. This is our system results. 95% accuracy, then 85% is our quiz evaluation. Engagement has increased by 28%, and the report time has decreased by 40%, compared to other systems, and the usability score is around 92%. And what are the limitations? The scale, duration, privacy, and integration. These are the four things that are of main concern. So we are working on these things to improve our system and get better at our system. So future directions, like we can implement the ML model, then we can use the blockchain credentials to make our system more robust and authenticated and more full of privacy. Yes, thank you.
Yeah, thank you so much for your presentation. Just I have a one query. Have you
Yes.
compared any case study with your another model with your software
Yes, sir.
that you have
Like we
showing that percentage only validation which is created or generated by your system. Okay,
Right,
that
sir.
validity, validation result, you ever check with another model or another platform?
Sir, in our research paper, we have compared around 25 previous research papers, and in that Moodle is one of the prominent tool which is used worldwide.
Yeah, I know, I know,
But
I know.
it
App
has
tutor is there, module is there,
yes, sir.
lots of platform is there. That's why I'm asking, have you compare with those platforms? Your platform is more give more good, better result to comparatively other
No,
platform
sir.
like model.
No, we haven't done a specific tool comparison, but for through simulated data that we have generated these results and which are integrated to our system only.
Okay, thank you. Over to ma'am, if you have any query.
Thanks, sir.
Thank you for your presentation. The proposed system demonstrates how data-driven educational technologies can enhance both teaching effectiveness and student engagement. How scalable is the platform for implementation across multiple institutions?
Yes, so the scalability of this this project can be extended to an autonomous product. We have tested this for around 100 students on a simulated system. We are planning to implement it at our own university. Uh, Around 500 to 600 students that we are planning to first integrate them with the system, and then through the feedback and through the results of the uh, uh, progress, we are going to implement it and make it a product soon.
Okay, thank you.
Thank you, ma'am. Thank you, sir.
That's enough.
Thank you for the presentation.
Yeah,
Would
Tanish,
like,
may I
yes,
know how many presenters is available?
presenters are available.
How many we have more
Okay.
presentation?
Yeah. There are total 4 presentation left as of now.
Okay,
Yeah.
please.
Okay. I would like to call the next presenter, Alita Fabregas, for the paper title Rivercast, Forecasting Markini River Level Using Autoregressive Transformer with Kernel PC and Euclidean Kernel.
Hello, good morning.
Yes, you can
Good
start it, Tanshi.
afternoon. Yes,
Good
okay,
afternoon.
thank you. Okay, good afternoon to all. So our proposal, our study is all about rivercast forecasting Marikina river level using autoregressive transformer with kernel PCA and Euclidean kernel. I am the one that will be representing the group for this presentation. According to Philippine Atmospheric Geophysical and Astronomical Services Administration, our PAG-ASA, the Philippines experiences an average of 20 storms per year, and 8 of them reach landfall. This phenomena can cause excessive rainfall, resulting in flooding. Flood cyclones, tsunamis, and landslides have caused 70,000 deaths and $23 billion in casualties since 1990 in the Philippines. The Philippines' location in the Northwest Pacific Basin made it prone to precipitation, producing meteorological phenomena, including tropical cyclones, thunderstorms, and the intertropical convergence zone. According to PAG-ASA, as the National Meteorological and Hydrological Services Agency, of which is mandated to provide protection against natural calamities and to ensure the safety, well-being, and economic security of all the people, the Philippines experiences an average of 20 storms per year, and 8 of them reach landfall. This phenomena could cause excessive rainfall, resulting in flooding. This is the picture, an example of the picture of the flooded Marikina River for the year 2023. And we have the focus of the study. Because of this condition happened to Marikina River, the flood risk is extremely high in the said areas due to the size of the Marikina River basin and due to the highly urbanized communities within Metro Manila and Rizal Province. Our solution: predict the water levels of the Marikina River, specifically at Nangka and Santo Niño stations, warning posts for the next 48 hours using the meteorological data. As a disaster response, the application provides direction to the nearest evacuation center, and the application also displays a list of emergency directories and allows users to send their location for quick emergency response. Current flood forecasting systems use deterministic or statistical models to produce forecasts and flood warnings. Deterministic models utilize scientific formulas, while statistical models analyze patterns in historical data to forecast potential flooding. However, spatial changes cause forecasting inaccuracy in both approaches. We have two related literature that were basis of our conceptual framework. We have the kernel PCA in time series forecasting, TIBS, and through project the input into engine vectors. This method extracts spatial pictures while also preserving the original information. Then we have the transformer model, Jiang Xing, Zhu, Hongshan Fan, Minghan Lu et al. 2023 forecasted water level in Poyang Lake, China, using a transformer-based model. These are the other literatures that were connected to our proposal. And we have one from the study also focusing with the Marikina River, the near real-time flood extent monitoring in Marikina River, Philippines. Model parameterization using remotely sensed data and field measurements. They're using HEC. HMS integrates various hydrology components such as infiltration loss. And then there is a research gap. HEC HMS simulate physical phenomenon, but requires a large number of variables, making them complex and often difficult to calibrate. And we have our part of the system architecture. We have the kernel principal component analysis. So we have the kernel principal component analysis, selects relevant features or variables at each time step. Then we have the positional encoding embed sequential information into the input. The mass self-attention extracts temporal patterns within the input by assigning weight to each time step based on its relationship to other time steps. Add and norm stabilize the training and mitigates the vanishing gradient problem. We have some of the formulas that we use in our study. We have the kernel PCA first calculate the relationship between spatial variables in the input and removes multicollinearity. The positional encoding calculates the positional information using sine and cosine function of varying frequencies. Then we have the implementation of self-attention in the study as autoregressive. We have the layer normalization and residual connection, stabilize the training and mitigates the vanishing gradient problem. Finally, the feed-forward network is a three-layered neural network that takes the normalized layer and produces forecast values. We have the agency, we have the data stations, number of records, the date, and then we have the Pag-asa, our source, the historical weather data, rainfall. These are the three variables that we were able to select coming from our PCA. So we have the rainfall, precipitation, humidity. We have the three stations, Nangka, Tomana, Santo Niño, Montalban. And then we have 96,492 records. And then we have the date 2012 to 2022 for us to predict. Then our study collects meteorological, hydrological, and topographical data from the Philippine government agencies like Pag-asa, MMDA, DPWH, and Marikina City Hall. These agencies maintain river monitoring posts along Marikina River and weather stations in the area. These agencies installed ultrasonic sensors on Metro Manila River bridges to monitor river levels to fill the missing meteorological data, historical information as obtained from Open Weather API. The goal of the prototype is to forecast water levels in advance to determine potential flooding. 80% of the collected records from January 2012 to December 2019 are allocated for training, while the remaining 20% from January 2020 to January 23 are utilized for testing. And then we have our model to be evaluated. We have the rolling window testing. So initially, we use rolling window testing So this study uses that testing to measure the accuracy of the models. The time series data is divided into multiple overlapping time windows. The forecasting model takes the data within the input window to predict the data within the forecast window. The study then used mean absolute error to measure the prediction accuracy within the forecast window. This process is repeated as the window rolls or advances through the testing dataset. And then we have the models of the transformer by Jia Xingzhu. And then we have the transformer with kernel PCA and Euclidean kernel, our model. And then in forecasting the river level at Nangka, Santo Niño, and Montalban, the autoregressive transformer with kernel PCA and Euclidean kernel has lower average mean absolute error. Moreover, the standard deviation of mean absolute error from autoregressive transformer with kernel PCA and Euclidean kernel is 0.0165 level lower. The p-value between their mean absolute errors is 0.002, which is less than 0.05, thus indicating significant difference in accuracy. And we have the comparison of the model. So we could see from Nangka, Santo Niño, Montalban, this is actually the model by Jian Xingzhu, Hongshan Fan, and Minghan Lu, and of course other. We could see the gap in between the prediction and then the actual flood level. So from this, we could see that Santo Niño has wider gap. And then with our model, we have the transformer model with kernel PCA and Euclidean kernel captured seasonal patterns better. It forecasted that the river levels are at their peak during the months of July to November and its lowest during the months of April and May, which makes sense considering the seasons in the Philippines. Using our model, we could see that the gap is said to be smaller. And then with respect to Santo Niño, we could see also that the gap is getting smaller. And then we have the conclusion. The prototype was able to forecast river levels at Nangka, Santo Niño, and Montalban using historical weather and water level data. Compared to the latest water level forecasting modeled by Zhu, Fan, Lu, the autoregressive transformer with kernel PCA and Euclidean kernel, significantly more accurate and robust because of its ability to understand the seasonal patterns. By integrating this model to a web service, the prototype can warn citizens of impending river overflow hours in advance, thus reducing casualties. Then we have the recommendation. The transformer models have made remarkable advancements in learning historical patterns, but the data-hungry nature of deep learning models poses a significant challenge. To take note, we have Santo Niño, we have a bigger problem because the Santo Niño agency or station was not able to give us the data set that we really need for this study. The study recommends future researchers to improve the data efficiency of forecasting models. One common strategy is data augmentation and synthesis where researchers generate additional high-quality training samples from existing data. And we have the recently application that we were able to develop coming from the study. So we have the mobile app. The mobile app is called Flood Watcher. And then this is actually helping us to predict the water level after the water level after 4 hours. The water level will be predicted after 4 hours and then the next 4 hours. So we have the sample, the screenshot of our prototype, and then we have the following parameters that will be predicting the water river level. And then these are actually the center, if ever, the evacuation center, which could be directing the victims of the flood to go there at that particular place. That will be somehow detected and then supported by the mobile app.
Excuse me, ma'am. It's just a gentle
Yes.
reminder that the presentation time is up.
Okay. So this is actually the end of my presentation. So I think that's all for today. So again, thank you and mabuhay. Thank you.
Yeah, nice presentation. I don't have any question. Over to madam. If you have any question, please.
Okay, thank you.
Thank you for sharing your valuable research with us. Thank you very much. I have a question. How could the model be integrated into existing early warning system used by local authorities?
Yes, actually, we are now to still improve our model, because if we are going to implement this into the full implementation, the MMDA, the Pag-asa, and then of course the Marikina, the local place of this Marikina River, they're actually asking us for more testing so they could easily implement this model that will be integrated in the mobile app. The mobile app is actually finished, completed, but still they are requesting for more testing. So if ever that this will be used during the rainy season, so we could assure them that the output, that the prediction of this particular mob app will be more reliable, and then they could be easily using it.
Okay, thank you.
Yes, thank you. Thank you very much.
That's enough. Thank you.
Thank you.
Yes. Thank you so much for the presentation. I would like to call the next presenter, Christina Himawan, for the paper title Smart Technology and Integrated Systems in Subscription Hospitality, the role of service personalization in guest satisfaction. Yeah. You can start your screen. Yeah.
So, good afternoon, everyone. My name is Christina, and I will present our topic about the smart technology and integrated system in subscription hospitality. As a business hotel management student, we recognize that hospitality is not longer just about the physical rooms and the basic services. Today, success depends on digital convenience, personalization, and the long term engagement. This presentation will explain how smart technologies and hospitality ecosystem drive customer satisfaction and specifically with the emerging subscription-based business models. So let's begin. Let's us establish our foundational context. This research, the hospitality industry in Southeast Asia currently undergoing the profound digital transformation. This shift is driven not only by the needs of the optimized operational efficiency, but also the mandate to elevate the overall guest experience. Concurrently, we are witnessing a significant paradigm with shift in business models. The industry is transitioning away from the traditional isolated transaction towards sustainable membership and the subscription-based structure. Consequently, the study investigate the intersection of these two threads, specifically, we examine how digital adoption and business models innovation collectively influence and drive customer satisfaction. In our research, there's two highlight major that interconnected. The first one is the IoT adoption. Hotels are increasingly integrating Internet of Things frameworks such as the smart locks, voice assistant, the automated climate controls. These technologies enable the operation to automate routine operation, optimize resource utilization, and deliver real-time environmental adjustment tailored to the individual guest preference. Second, there's the subscription business models that inspired by the software as a service framework. Hospitality brands are pioneering recurring subscription structure. This strategic shift allows organization to secure predictable of revenue stream, stabilize seasonal demand fluctuation, and the successfully transition traditional transactional encounters into the long-term customer partnership. There is the operational as architectural of contemporary hospitality relies on the three core interconnected pillars. First is the IoT device, the function as the primary physical and digital touchpoint deployed to the capture granularly real-time guest preference and behaviors. Second is the integrated system facilitate the critical data consolidation by unifying historical fragmented database, specifically property management system (PMS) and the customer relationship management into a single centralized guest profile. Finally, the subscription framework serves the overarching business model innovation, effectively shift the industry strategic focus away from the isolated transactional state and toward the continuous ecosystem and of enduring member recognition and proactive engagement. While the technology is widely discussed, there's a literature has the critical gaps. The first one is a isolated focus. Previously, the studies often analyze a single technology in isolation, ignoring how different tools interact with a larger ecosystem. Second, the short-term metrics. Users are rarely examine the long-term customer satisfaction in subscription context, where the guest expecting ongoing and seamless reconnection. The third is the data fragmentation. Isolated database create the surface friction, forcing returning guests to repeat their preference. On our study bridges, there is the gaps by exploring how smart the technology and integrated system work together to enable personalization and how that's the personalization drive the long-term satisfaction. The section two, it's ours the
Please
our
go to
literature
your
review. Here's the
findings, dear
established
presenter. Please go to
sorry.
your findings and discussion. Go to your findings and discussion. No need to discuss on literature review.
All right. So we will go to the research methodology that we adapt the quantitative research approach to empirically test the relationship between the smart devices integrated system, service personalization, and the customer satisfaction. This design allows to satisfactorily measure the strength and direction of this the variable and the subscription context. So our empirical design consists of the following components. First, the approach, a cross-sectional survey collecting data at the single point in time. The target population is the hotel user in the greater Jakarta, I mean the city around Jakarta, like Jakarta, Bogor, Depok, Tangerang, and Bekasi, with the experience in smart hospitality services. And the sample that we use, there is 400 valid responses collected via purposive sampling. And the analysis method, we use the equation modeling using the smart PLS 4.0, which is still ideal for analyzing complex direct and mediating relationship. So our data shows that the sample is heavily dominated by digital native, especially Gen Z and the millennials. The demographic is highly familiar with the mobile apps, ecosystem connectivity, and the on-demand digital services because they are already subscribed to streaming content and the lifestyle platform that represent the primary target market for the subscription-based hospitality, making our samples highly relevant to the study focus. The structure model yield a significantly result with all the hypothesis paths supported at the p-value 0.000, while the both smart devices and the integrated system significantly impact the model surface. Personalization emerged the strongest direct predictor for the customer satisfaction. This proves that technology alone is not only enough, its true value lies how effectively a hotel leverages to deliver tailored highly personalization guest experience. The statistical models demonstrate robust explanatory power as evidenced by our key findings. Customer satisfaction, the R square is 70%.9. That indicates it's nearly 71% in the variance in the customer satisfaction is accounted by the variables within our models in academic terms. And R square value is high represent for a strong and highly reliable models. For the service personalization, R square are 56.7%. This statistically validates that the back-end integrated system and the front-end smart devices serve as a crucial delivers in delivering customized guest experience. The technology synergy hypothesis, this empirically result confirm our technology synergy hypothesis. The data is clearly shows the structure value of creating pipeline. Smart devices act as a collection touch point for the guest data. Integrated systems centralize and unify this data, breaking down silos, and the surface personalization acts as the final catalyst that translate the unified technology framework into the measurable customer satisfaction. For the hotel operation, the main takeaway is straightforward. We must eliminate the data silos. To sustain the long-term value of the hotel subscription model, it's essential to implement one guest, one profile strategically by seamless connecting the property management system or PMS, CRM, and the all digital touchpoint into a single unified data flow. Hotels can be achieved three critical goals. First is instant recognition, identify and welcome members immediately at the touch point. Second is continuous personalization, deliver a tailored and consistent experience through the entire guest journey. Third is initiate the churn. Build a stronger relationship that effective retain the members and prevent cancellation. Ultimately, this integrated approach ensures that technology active drives customer loyalty. In conclusion, while the implements of the smart technology and integrated system is foundationally to enhancing guest satisfaction, personalization emerged as the critical differentiator, the vital link that translates technological infrastructure into the enduring customer loyalty. The limitation and future direction, the study scope, the generalizing of this research is concentrated by the cross-sectional design and the specific focus on the Greater Jakarta region, and the future research to build upon these findings. Subsequent studies should aim to expand more geographically scope to capture more diverse range and hospitality environments, employ longitudinal methodologies to track and observe the evaluation of the customer loyalty over time, investigate the complex interplay between the price sensitivity and the data privacy concern and technology adoption. Oh, as we close, let's remember that technology should be enhance the human connection, not replacing it. The brands that master this balancing, safeguarding privacy, and delivering unforgettable personalization experience really to industry. Thank you for your time today. We are now ready to take your question, and please feel free to share your thoughts. Thank you.
Yeah, thank you so much for your presentation. Just I have one query only. So your study is based on subscription-based hospitality, am I right?
Yes, that's correct.
Then tell me, how does it differ from traditional hotel service model?
Sorry?
Yeah, how it is differ from traditional service model?
Oh, I mean like the traditional service model, like you go into the hotel and then you do the check-in and you buy the room on the counter. But this one, like you already do the subscription, like you having the loyalty card, but in a electronic way. That's the
Okay.
differences.
Okay, got it. Over to ma'am. So if you have any question, please. Thank you.
Thank you for your clear presentation. I have a question. Do you think service personalization could become a competitive advantage for hospitality providers in the long term?
Yes, of course. I mean, like the service personalization, like they giving the best for their customer, right? Especially their a loyal customer that they will recognize them immediately. They will come back for their best service that the hotel give to the customer.
Okay, that's enough. Thank you.
All right. Thank you, Miss.
Thank you for the presentation.
Thank you.
I would like to call the next presenter, I Win, for the paper title Understanding the Effect of Temporal and Attention Learning in GM Flow Based Fault Detection Systems. You can start sharing a screen.
Hello,
Yes, you're
can you
audible.
hear me?
Yeah.
Yes. Good afternoon, respected chair, distinguished professor, and all participants. Today, I'm honored to present my presentation. My research title, Understanding the Effect of Temporal and Attention Learning in GM Flow-Based Fault Detection System. This slide outlines the key session of my presentation. Let me move to next slide. In this result, 3-4 detection model based on GM flow based on GM flow were developed and evaluated shown below. The performance of this model was evaluated using the URFT dataset, LITUI dataset, and their combined dataset. According to the experimental result, the third model achieved the best performance across all datasets. These results indicate that integrating CNN, TCN, and attention mechanism with GM flow provide an effective architecture for accurate fault detection system. Let me move to the next slide. For our major concern, especially for elderly people because they can cause serious injuries and health risks. In this result, optical flow is used to capture motion information between video frame and GM flow is employed for accurate motion estimation. TCN is used to learn temporal motion pattern and attention here focus on important feature and CNN express spatial motion feature. Let me move to the next slide. Despite significant research for reliable fault detection is still a challenging problem in real-world situations. Variable sensor-based systems require users to work the device continuously, which may not only always be practical. On the other hand, many CNN-based approaches mainly focus on spatial features and may not fully capture temporal motion pattern. Because of this limitation, existing methods can struggle with complex human movement, diverse environment, and accurate for recognition. Therefore, the more robust architecture that combines both spatial and temporal learning is needed to achieve better fault detection performance. Let me move to the next slide. Previous results have shown that CNN, TCN, and attention mechanism can improve fault detection performance. However, most studies focus on this technique individually. Only limited research has explored the integrating of GM flow, CNN, TCN, and attention within a unified framework. Therefore, the effectiveness of such a combination architecture for fault detection is still not fully understood, which forms the main motivation of this research. Let me move to the next slide. The objective of this research is to develop GM flow-based fault detection architecture and evaluate their performance. This study investigates the role of TCN, attention CNN, and improving fault detection accuracy. Based on the experimental result, the most effective architecture for fault detection system is identified. Let me move to the next slide. Overall methodology begin with video preprocessing. First, the input video are processed through frame extraction, resizing, and sampling to generate consistent frame sequence. Next, GM flow is used to estimate optical flow between consecutive frames and capture motion information from the video sequence. The extracted motion features are then fed into three different architectures as shown below. In this architecture, TCN is responsible for learning temporal dependency and motion pattern across frame. The attention mechanism here the model focus on important temporal feature while reducing the influence of irrelevant information. In addition, CNN is used to extract spatial motion feature before temporal learning. Finally, a fully connected layer perform a classification and determine whether the input sequence belong to the for or not for. Let me move to the next slide. This figure illustrates the overall architecture of the three methods used in this result. Next, I will discuss the dataset. This table presents the datasets used in these results and the corresponding number of video samples for all datasets. The data were divided into training, validation, and testing sets using a ratio of 70, 20, and 10 respectively. Let me move to the next slide. This table shows the hyperparameter settings used for all experiments to ensure a fair and consistent evaluation. The same training parameter were applied to each model. The key settings are summarized as shown in table. Let me move to the next slide. From the experimental evaluation, it can be observed that the combination of the third model consistency outperformed the other model on all datasets. This improvement is mainly due to the effective combination of spatial feature extraction, temporal learning, and attention-based feature enhancement. As a result, the model was able to better recognize four related motion patterns while monitoring strong performance across different datasets. Overall, the findings suggest that the proposed architecture is effective and suitable for vision-based fall detection in real-world scenario. Let me move to next slide. This slide presents the best experimental result on the URFT dataset on three proposed models. This slide I present the best experimental result on the Li2I dataset, and this slide is the present the best experimental result on the combined dataset. Let me move to next slide. To conclude, three GM flow-based architecture were developed and evaluated in this result. The experimental result indicate that the third model is the most effective architecture, achieving the best performance and generalization capability. The combination of DCN attention and CNN contribute to improve feature learning and fraud detection accuracy. Nevertheless, challenges related to limited dataset and real-world complexity still remain and provide opportunity for future improvement. Let me move to next slide. As future world, the proposed framework can be tested on larger dataset and in real-world environment. In addition, more advanced techniques such as transformer-based temporal learning, enhanced attention mechanism, and multimodal feature fusion can be explored. This direction may further improve the accuracy, robustness, and generalization performance of the fall detection system. The reference used in this are as follows. This is my reference. Thank you very much for your attention. I would be happy to answer any question.
Yeah, thank you so much for the nice presentation. So I
Okay.
don't have any kinds of question. Over to madam. Madam, if you have any question, please.
Thank you for sharing your study and funding. I have a question. What challenges remain before deploying this solution in real-world healthcare or assisted living environments?
Challenges variation in environment, camera view, lighting condition, and human action are still challenges in my research.
Okay, thank you.
Thank you, sir.
Thank you for the presentation. I would like to call the last presenter, Ruhi Sethi.
Excuse me, it's presentation number 9?
Yeah, this is the last presentation.
Last presentation.
Yeah.
Okay, thank you.
Ruhi Sethi.
Hi, good afternoon. I'll just
Good
attach
afternoon.
my presentation now.
Yeah.
I hope my screen is visible.
Yes, it is visible.
Okay, great. Since I'm in UAE, so good morning if anyone is joining from the UAE, and good afternoon. The topic of my presentation today is the Human Digital Trust Bridge Framework, which is mediated by mobile governance and ICT adoption in rural India. And I'll be presenting on behalf of my co-authors, that is Dr. Sambram and Dr. Prachi. Now, before I move ahead, so today I'll talk why people in rural India often don't use government apps, even when they own a smartphone. So the short answer here is trust, but trust is more complicated than we usually think. So let me walk you through it. Now, phones are everywhere, as we all know, and adoption lags. So the puzzle here is that there are 600 million Indian users who use mobile internet, and the government has invested in the application since 2015. Yet in many villages, people either they're not aware of the applications or they are not using the applications. So the problem here, it is not the mobile or the signal, it is the trust. Now that's the catch. So most research who have discussed about trust, there's a one big over here. Consider this, as an example, a doctor who's just telling you to be healthy. That is not going to solve your problem on day one, neither in near future. So, again, it is not going to fix. So similarly, rural users also face low literacy, weak connectivity, and fear of technology. So we need to break that trust down. Now, so the question here is that, what are the different kinds of trust and how do the government actually turn into someone, that is the people in rural India, using the applications? So here are three contributions that we are making. First, as we can see, multidimensional trust typology. We have used theoretical, conceptual model here. Then there are three bridge dimensions and some propositions, which I'll discuss in the upcoming slides. Now, how we build the framework. So as I've informed you, it's a conceptual paper. So we have built from the existing research from 2020 to 2026. We have seen how each study have described trust, and then we found 4 hidden types of trust. And then again, we have used different well-known theories and tested our idea against two applications. So our grounding is quite strong. Now, trust, again, like I've said, it's 4 types based on the existing literature. So I'll give you one example here. Think of Sunita, who wants her pension on the application. Does she trust the government with her idea? So here we are discussing about the first trust, which is institutional. Um, does she trust the helper at the kiosk? That is the intermediary. Then does she trust the app to be safe? That is technological. And the last one, the villagers, that is the social. Now think of it as neighbors, or you can think of it like a word of mouth, where people who are using the application, they spread the word, it is trustworthy. However, in rural India, it is quite opposite thinking in comparison to the cities. Now, the three bridges here are human, low technology, and social. So, how do people who don't trust the application still end up using it? How? Through these three bridges. So, first, let us say a helper. Think of it as a human, someone who's using the application with you. Think of a simple screen like low technology, maybe a voice instead of typing. So it feels less scary. Now, social, again, they're part of the neighbors. So if your neighbors are using it, it is probably you will also use it. So again, in social, if the people in the village, they are using the application, with the help, of word of mouth, we can spread that application. So each bridge that is discussed over here, again, is backed by theory. Now, the main message of these bridges is a bridge can make up for weak trust in the app itself. Now, this is, the whole picture of what we have discussed, the 4 types of trust, the bridge mechanism, and then again, what is the output over here. So the whole idea, if you see 4 trust, that is feeding the 3 bridges. Now, the bridges make this service feel worth it. Now, that's what makes someone say, I will use it. Because that is what our idea is, that why people are not using the government application. So if we have the dimensions, if we have the bridge mechanism, the answer is adoption. So the bridges can change like literacy, fear of technology, and that's like a helpline. So trust can grow or break over time. Now, there are 8 testable propositions. So for researchers, we can predict these. Now, again, I'm not going to read all of them. They're here for the paper. Now, there are 2 examples that I can state here. Now, a voice screen can cancel out any fear of technology, and one bad experience can spread distrust unless there's a way to repair it. Now, the panel here on the right-hand side, if you see, it's what are we expecting to change with the results. Now, as I mentioned earlier, there are 2 applications that are mentioned here in the paper, which is Umang and Sanchar Sathi. Now, Umang is a very successful application in India, and it worked very well because people trusted the government. Helpers signed them up at service centers. There was word spread in the community. However, Sanchar Sati failed. Now, privacy scare hurt trust in the application. There were no helpers, and word of mouth spread, excuse me, fear instead of confidence. Now, with no way to repair the trust, it collapsed. So same framework, as we can see, we have discussed about institutional trust, we have discussed about low technology, we have discussed 4 types and bridges. Both of them applied. However, one succeeded, that is Umang, and another application, Sanchar Sathi, failed. So what is the takeaway from here? Now, if we see, we need to understand what should the government do. So adoption is across all the country. So government should fund helpers and training, not just application and towers. So add a call for helper button and a voice mode. And researchers can test our 8 predictions or propositions. The one thing to remember here is success isn't about better technology. It's about building the right bridges of trust. Thank you so much, everyone, for listening to my presentation, and I'm happy to take any questions.
Hello, am I audible to you?
Yes.
Yeah.
Yes.
Just in the last second slide, okay? Just go to Sanchar Sathi and Umang. That you have
Yeah.
mentioned that Umang is more stable than from this is somewhat this one Sathi.
Yes. Umang is more successful than Sanchar Sathi. They almost had
On the
similar
basis of
bridges.
what
Yes.
study you have done, any comparative study or any you have received any kinds of input for data validation or something like that? On the what basis you are saying that Umang is more suitable than?
Yes. So what we did, we had an existing literature. We had almost 80, studies. We did not do a comparative study. However, we did analyze those 50 out of 85 we had 50 studies. So from those studies we could analyze a pattern. So there are different types of analysis of pattern as well. One that we can do is thematic, another we can do is bibliometric study. So we have not focused on bibliometric because that is either SLR framework or a Prisma framework. We have not focused, but because the literature was quite less, it was not too much that we can do with the data. So wherever we can find information, we incorporated, and based on the existing literature, we came up with the decision that yes, that Umang is more successful in comparison to Sanchar Sathi.
Fine, then thank you. To Madam, if you have any question, please.
Thank you for your nice presentation. What would be the next step of your research?
So we are actually focusing on testing the 8 propositions empirically. And we will see whether, in a conceptual versus empirical, what we have mentioned that is correct. And if there's any other way forward to ensure that people in rural India do adopt the application better in comparison to people who are living in the urban areas. So our next step is definitely the empirical testing.
Okay, thank you.
Thank you so much.
Yeah. Okay. I sincerely thank all the authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the virtual conference. We'll be very happy to have you in the next version in 2027. To all the presenters, they would be getting their digital certificates through email within 2 working days. The publications would be live within 7 to 8 months. Kindly cooperate with the team of TIPS 2026. I also thank our session chairs, Amal Azarwal and Hirak Jyoti Hazarika, for chairing this session.
Thank you.
Thank you, Tanish, for nicely you have conducted moderation part. Thank you, Madam, for joining me for sharing the session. Thank you so much.
Yes, thank you so much. I also request everyone to kindly switch on their videos to take a quick photo.
Thank you. Thank you. I would like to sincerely thank all the presenters for their valuable contribution. And I also thank the technical and participants. Thank you.
Thank you so much, everyone.
Goodbye.